charge, right? Nuclear charge is actually the positive charge of the nucleus. Positive charge with the nucleus possessed, okay, and it is determined by the number of protons in the nucleus. So greater the nuclear charge is, stronger the attraction the nucleus has for electrons. As the nuclear charge increases, electronegativity also increases. Okay. So the second factor which affects electronegativity is your atomic radius. Okay, second factor is atomic radius. Can you see my screen?
Yes.
So the second factor is your atomic radius. So you know what is an atomic radius? The distance from the nucleus. Okay, for example, this is my atom, which is positively charged. This is nucleus, right? And these are my electron shells. So if suppose this is having 3 electron shells in this atom, so the distance from the center of the nucleus to the outermost electron shell, it is called the atomic radius. Now, how this atomic radius affects electronegativity is that when the atomic radius decreases, nucleus is closer to the bonding electron, right? So if it is closer, then it is more powerful to attract electrons. It increases the atom's ability to attract electrons, right? So if you have a smaller atomic radius, so you have greater electronegativity. Okay. So we understood from this point that electronegativity, it is inversely proportional to atomic radius. If atomic radius is smaller, then electronegativity is high. The tendency to attract pair of electrons is high. Example is, if you move across a period, atomic radius decreases, right? Because if we move down the group, then atomic radius increases. And across the period, your atomic radius decreases because the nuclear charge also increases. And electronegativity increases. Okay, as I told you, nuclear charge increases, so electronegativity increases from the first point. Example, fluorine versus lithium. The electronegativity of fluorine is greater. Okay. Similarly, down a group, atomic radius increases. Why? Because number of shells increases, and as the number of shells increases, atomic radius also increases. So we understood from this point that if electronegativity increases, atomic radius will automatically decrease. And if atomic radius increase, electronegativity will decrease. So if you compare fluorine and lithium, fluorine versus lithium, so you know that fluorine have higher electronegativity. So it have a smaller atomic radii than lithium. Is it clear?
Yes.
Write down the second point, which is under the heading that factors which affect the electronegativity.
Okay. I'm done writing.
So the third point is your shielding effect. Okay. Factors affecting electronegativity. Third point is shielding effect. So what is shielding effect? Shielding effect is the reduction in the effective nuclear charge experienced by an electron due to the repulsive forces of inner electrons. Remember the diagram we studied in the last class, and this is your nucleus. These are my inner electrons and these are my outer electrons. So shielding effect means these inner electrons, they are shielding, they are protecting these outer shell electrons to reach the fully positive charge of the nucleus. Okay, so they just reduce the effective nuclear charge, okay, by experienced by an electron of the outermost shell due to the repulsive forces, because both these electrons, they have negative charge, so they repel each other. Okay, so this is your shielding effect. And how it influences electronegativity? So when inner electrons, they shield the outer electrons. Shield means protect. So when inner electrons, they shield the outer electron to reach the full charge of the nucleus, it becomes harder for the nucleus to attract electrons in a chemical bond because these electrons are continuously repelling it. Okay, so obviously your electronegativity would decrease. So the greater the shielding effect, lower the electronegativity. Example is in a large atom like cesium. Cesium, it comes after in a group 1 element, lithium, sodium, potassium, rubidium, and cesium. So these are your group 1 elements. So as you know that as we go down the group, atomic size increases. So cesium is very large. Now cesium is very large. That means there are many inner electrons in cesium. So the inner electrons, they obviously shield the outermost electron from the full charge of the nucleus. So it is less electronegative as compared to the smaller atoms like fluorine, where the shielding effect is minimal. So the cesium is not electronegative. It is the most electropositive element. Is it clear?
Yes.
So write down the third point.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-Level. Start learning with us today.
I'm done.
So the next thing is polarity in the molecules. What is polarity? Polarity means poles. Okay. So when the electronegativity values, as we have studied in the Pauling's electronegativity scale, so when the electronegativity values of two atoms forming a covalent bond, they are same. Then the pair of electrons it is equally shared. For example, H2. Okay. The value of electronegativity of hydrogen is 2.1 approx. It's also 2.1, right? So electrons in one bond you have how many electrons? 2 electrons. So they are shared equally. Okay, so we say that this H2 is non-polar. No poles are developed here. Similarly for chlorine, Cl2, because both the chlorine atoms have same electronegativity. Okay, they are attracting the shared pair of electron equally, so no poles are forming. Bromine is also non-polar. But when a covalent bond is formed between two atoms having different electronegativity values, then the more electronegative element attracts the pair of electrons in a bond towards it. The best example is hydrogen fluoride. So you know that the electronegativity value of fluorine is highest, 4.0, right? And hydrogen, its electronegativity value is approx 2.1. So the electrons, both the electrons of this bond, they are taken up by fluorine. Okay, so that means fluorine electronegativity power is higher. Tendency to attack the shared pair of electrons towards itself is higher for fluorine. So we have poles which are developed in this. We have H positive and F negative. Okay, so since fluorine is attracting electrons, okay, so that's why it is becoming fluorine partial negative. This symbol is of partial. And hydrogen becoming partial positive because hydrogen is because electrons are losing from hydrogen, they are not completely losing. Otherwise, they'll form an ionic bond. As we have studied in the ionic bond, they are transferred. So from like this, if you have this bond, then electrons are coming here towards the side of fluorine. This is first electron, this is second electron. So fluorine is becoming partial negative and hydrogen is becoming partial positive. Okay. It is not an ionic bond. It is not H plus and F minus. Only there are partial shifting of electrons. Is it clear?
Yes. I'm done writing.
So as a result, the positive charge does not coincide with the center of the negative charge. We say that the electron distribution is asymmetric. The two atoms are partially charged, not completely partially charged. So the less electronegative element, they have a partial charge, delta positive, and the more electronegative element, which is fluorine in this case, it have a partial charge, delta negative. So now we can say that this bond is polar or it has a dipole. Di means two and pole means polar. That means it have two poles, positive poles and negative poles. So this HF is a polar molecule, while your H2, Cl2, Br2, they are your non-polar molecules. Okay.
Okay.
Similarly, see the HCl also. The electronegativity difference of hydrogen and chlorine is also greater. So chlorine will attract the shared pair of electron towards itself. So you will write it like this. Arrow. You have to show the dipole using an arrow, in which you have this arrow, which is pointing here. It represents a negative charge. And if you make a cut here, it represents a positive charge. So this is the direction of the dipole. This is the direction of dipole. This is correct. If you make it like this, then it would be incorrect because here you are making the positive sign nearest to chlorine. So it is incorrect and this one is correct. This is the sign of dipole. So write down this. Done.
I just finished.
So draw this direction of dipole.
I'm done.
As the difference in electronegativity values of the atoms in the covalent bond increases, the bond becomes more and more polar. Degree of polarity, it is measured as a dipole moment. Dipole moment is what? It measures the degree of polarity of a molecule. It is shown by the sign this. This arrow points to the partially negative charge. This is your partially negatively charged end of the dipole, and this is partially positive. In molecules containing more than two atoms, we have to take into account the polarity of each bond, and the most important is arrangement of the bonds in the molecules, because we'll see some examples where there is a difference in electronegativity, but still the compound is non-polar, but still the bond is non-polar. So that's why I'm saying that these 2 points are very important. You have to see the arrangement of the bonds in the molecule. We'll discuss the examples in the next.
I'm done.
So for groups 1 to 17, the pattern of electronegativity is that electronegativity increases across a period from 1 to 17, and electronegativity decreases down each group, because atomic radius increases, so electronegativity decreases down each group. Okay, electronegativity decreases down each group. This means that chlorine is the most electronegative element in the periodic table. For the most electronegative element, the electronegativity order is, as I already told you, F, oxygen, then nitrogen, then chlorine. There is a very little difference in the electronegativity of nitrogen and chlorine, and then we have bromine. So these elements have the highest electronegativity in the periodic table, in which chlorine have the highest. After that, oxygen, and after that, nitrogen. So you have to remember the trends of electronegativity in the periodic table. Okay, so in the homework, you have to learn the factors affecting electronegativity. There are 3 factors which we have studied. Okay, nuclear charge, atomic radius, and shielding effect. So please revise all these notes before coming to the next session.
I'm done.